Welcome to this lesson. What we're going to do in this one is to download Anaconda. You can find Anaconda by going to anaconda.com/download and clicking on this little button. It will start downloading the file for you. Um, this is where we'll be coding for Python. Now, there are some text editors you can use, and there are also some other IDEs that some other developers for Python will use, such as PyCharm or Visual Studio. My favorite one is Anaconda Environment, mainly because of the ease of use, which derives from Anaconda managing the plugins for you or all the environments for you. It just makes your life much easier so you can focus more on coding part rather than maintaining the environment. So after you have downloaded Anaconda, what you will do is double click this to install it. It will take a while for it to open up, and then you click next, agree. If you're installing it for just yourself or all users, I'll just do it for myself. And I'll leave the settings as is and hit install. After you have installed Anaconda, you'll need to open Anaconda Navigator. Now, I have it open because it does take a while to open up, but you can find Anaconda Navigator by going to Start menu and clicking on Anaconda Navigator. Once you have it open, you'll see there's a lot of options, and it can be overwhelming, but you don't need to worry. A lot of these options we will not be using. Well, most of the option, if not all, we will not be using. Some developers will be saying that you start with Jupyter Notebook, as that's something really good for people who are starting off with Python. But what we'll do is we'll start with Spyder. And to open Spyder, you just click on Launch, and Spyder opens up. Now, before we get into coding on Spyder, what I'll do is I'll go to Environment. And the reason I love Anaconda Navigator is because it manages the libraries for you. It makes it very easy to install libraries, and libraries could be something about machine learning that you want to install. So it will tell you what libraries installed and the versions installed, and it will also tell you what libraries are not installed. And then you can, let's say you wanted to install this little library, you click on the little icon and click apply, and it will install for you. You can also update libraries. A lot of time I don't like to update libraries because having the latest library just means you might run into bugs that have because you're just testing the latest version. So that's why I hesitate to update the libraries. You can also create new environments. So I have created one already, but if you click on create environment, you can give it a name, and then you can select what version of Python you want to install. There's 2.7, 3.5. What I would say, stay away from 2.7 because a lot of people are moving away from 2.7 and running into Python 3. So you can choose any of the versions that you want to install and create the environment for. Hi everyone, welcome to the session on comments in Python. There will be many times when you will find yourself using comments in Python, and what we use that is to explain the code that we have written to make the code more readable, and it can also be used to prevent execution of code when we are using performing tests. So for example, I can type by pressing Shift and the number 3 button on the keyboard. This starts a comment section. So if I were to type, this is my program to discuss comments. And if I press the F5 button or the play button here, this will not do anything. We can also use, for example, x equals 1, which declares a value. And if I press the F5 button, this declares a value of 1 to x. And if you print it and press F5 again, you're getting the value of x printed here. But what if you don't want to print the value of x? Then we can type or press Shift to the number 3 button and run it. This will not print it anymore. We can also use it to explain the code that we have written in Python, and this will be very useful for yourself in case you happen to look back at the code a year from now on what you were trying to do or what the program was trying to do. And it can also be useful for someone who reads your code so they understand what the variables are doing or what the program is about. As is in this case, this is the program to discuss comments. And if I were to save this file, whoever opens it, they would understand what the reason for this file. Thank you for watching this lecture. I'll see you in the next one. Hi everyone, welcome to this lecture on numbers in Python. Before we get started on the numbers part, I just want to bring attention to assigning a variable. This is something we'll be revisiting later in the course to explore more on variable assignment, but to start with on the basics, we can call a variable any word or even a letter. For example, a equals 1. When we do that, we can call a as in print a, and this will give us the return value. Had I type 2, there's no way for me to call this value again. So if I were to click on Variable Explorer, we can see we have the variable called a, type integer, and the size and the value. Another thing that you can use a variable, unlike in other languages, in Python you can recycle variables. So if I were to type a equals 2, this will simply overwrite the variable value. I can also type something like text, a string value, and this will overwrite the value as well as the type. This makes Python really flexible in terms of variable assignment compared to many other languages. Now that we have that out of the way, what we'll do is clear variable section so we have a clean state here, and then we'll also clear the console so we remove the text. In Python, you can perform complex and basic arithmetic operations. Let's start with the basic 4 ones, which is math. In math, there's addition, subtraction, multiplication, and division. And to perform all these operations, we'll be using 2 numeric types. One is called integer, which is anything as a whole number. So 1, 2, 3, these are all integers. We also have values that are float, and this will be, and notice how the color changes. If I were to type int, this will be read by Python as integer assignment, and this will be read as float. If I were to type float, this would not work. So in Python is case sensitive. Float will be anything, for example, with the decimal point 10.0 or 11.0, 11.5, or 15.984. And then there's the third type, which is called complex. And this can be, for example, 1 to 8. Now we won't be focusing on the complex part, so I'll remove that and just focus on the integer part. So in Python, you can do multiple calculations. For example, 1 plus 1 will return you 2. You can also do subtraction, for example, 2 minus 2, that will give you an output of 0. You can have -5, -5, that will give you -10. You can also do division, such as 10 divided by 2, will give you 5.0. And notice how you get a floating point here. Now, what if you wanted to get a whole number? So you would type integer 10 divided by 2, and that will give you 5. And just as that, you can call float 2 minus 3. That will give you negative 1.0. Now, if you try to divide 1 by 0, you'll get an error because you cannot divide any number by 0. You can also do a remainder, or to find out if a number divided by 2 would be even or odd. So 2, it will be 13 divided by 2, that's 6.5. So it does not go equally into 13. Now, if you were to type something as 2 divided by 2, that's 6. And if you type 2, 12% times 2, that gives you 0. This is one way to check if the 2 or any number will divide into a number that will give you an even result. Now you can also do power, for example, 3 times 3 times 3, that will give you 27. And you can also type 3 times double asterisk sign times by 3, that will give you 27. Then there's another way to do the power sign in Python, which is to type 3 e to the power of 100. And I should type it like this. Equals 3e plus 100, and you get a float. And then there's also order of operations. For example, 10 plus 5 times 1 minus 1, that will give you 14. And the way this works is 5 times 1, add to 10, and then subtract 1. That gives you 14. So it's BEDMAS, which is break, expand. I think this is what they taught in the high school. Break, expand, divide, multiply, add, and subtract. Now, if you wanted to make the order of operation different, you can use parentheses. So, for example, 10 plus 5 times by parentheses 1 minus 1, and you'll get a different answer, which is 0. What it's doing is first it's subtracting the two numbers here, which will yield 0. And then if you add 10 to 5, you'll get 15, but 15 times by 0 will give you 0. And this is it for the numbers. Thank you for listening to this lecture. I'll see you in the next one. Hi everyone. In this session, we'll be talking about casting in Python. There will be times when you want to cast a number as a string. For example, you want to store phone number as a string, since we're not going to do any mathematical calculations on it. Or if you want to remove all decimals from a float literal, or to convert an integer to a float literal. So I'll start with integers. If I have x equals to 1.0, that will be stored as a float, as decimal point. What if I want to store it as an integer without the decimal point? Then I'll need to cast it as an integer, and that will change the type to integer. Similarly, if I were to have an integer that I want to cast as float, so y equals 1 as an integer, and if I want to cast it as a float, and when I run it, it will change to float with the decimal point. Now we can also have a phone number example. For example, a phone number equals to 604 123 45 6 7 8. If I run it, this is by default stored as an integer. But in databases, we try to store these things as strings because we are not performing any mathematical calculations. If I run this as cast as string, this will change to a string type. Thank you for watching this lecture. I'll see you in the next one. Welcome to this session on variables. Learning about variables is imperative because this is how you start to automate a lot of processes. For example, you go to the bank to ask for a business loan. The banker will ask you for details such as your address, social insurance number to look up your credit score, and to find any existing debts, income, expected revenue, and many other questions he'll be asking you. As you are answering the questions, he'll be typing these details into a form on his computer, and all of these things are being captured as variables. In the backend, all those variables, they're being stored in a SQL database, and at a later point, the variables will be used to determine the success of the application. For example, if you can be approved for a loan or not. In Python, you do not have to enter any command to declare a variable, unlike many other languages. For example, we will declare x equals 4. And you can see in the variable explorer section, x, which is the variable name, type integer by default, size of 1, and the value of 4. In other languages, you have to do a lot of other extra work to declare what type of variable it will be before you can even do an assignment. But Python keeps it very simple, which is why this is my favorite language. We can also type something as y equals 6, and you have another variable. Now, if you try to type x equals x plus y, you'll get a response of 10. Now, what if you wanted to store this output as, you can type z equals x plus y, and you have a value of 10 equals for a variable of z. You can also cast numbers as strings. So in this case, by default, Python will assign integer to any number. And what if you want to assign a number as a string? You might ask, why would we ever want to do that? Well, we will want to do that because, for example, phone numbers. We never want to store phone numbers as numbers because we will never do mathematical calculations on phone numbers. For example, I would type telephone equals 604 123 4 5 7 8 9, and we have an integer, and if we want to look up this number, it will, well, we would want to look up a string as during our search query, because we will never do any sort of calculation. So what we will do to store this number as a string value would be to cast it as string. So we will type telephone equals, and we will copy this value and type string. str stands for string, and if you type str in caps, Python will not read it. So Python is case sensitive in terms of how you call some of the basic elements. Closing parentheses, and now you can see this is stored as string. And if I try to add telephone plus 2, this will throw an error because you cannot add integer to string. Now, had I called, if I were to replace this value again, telephone equals, and it's stored as a number, and if I try to add 1 to telephone, you'll get a response of 790, which is just adding an extra 1. So this is how you can cast a different type to a variable. You can even cast a number integer as a floating point. For example, x equals integer, well, this will be integer, so let's call it float 1.0, or 1 actually, and you can see how x is a float value of 1. And if I were to type x equals 1, and then this is just an integer. We can also convert numbers to complex numbers, for example, and let's not use variables just to keep this screen clear. What I'll do is the variable screen and type x equals complex 1. And you can see 1 plus 0j, where j is an imaginary number. This becomes a complex number. You cannot convert complex numbers into integers, so if I were to type x equals complex, actually I'm trying to convert it back to integers, so x equals integer x, and you will get an error that you cannot convert it back to a real number. And this is it for the lecture on variables. I'll see you in the next lecture. Thank you for watching. Hi everyone, in this session we'll be discussing booleans. In programming, you may want to know if an expression is true or false. For example, if you wanted to know if a particular highway allows drivers to drive above 100 miles per hour. Or Google Maps telling you if a restaurant will be open by the time you drive to it. Or if someone is applying for a new credit card, that they meet the minimum requirements, such as income. We'll start with simple comparison operators. For example, we'll type print 15 greater than 10. Now, before I press the F9 key to run this line of code, I want you to ask yourself if the result will be true or false. Is 15 greater than 10. Now if I press F9, I'll get true because 15 is greater than 10. Similarly, I can type print 0, and in this case, I'm asking is 1 greater than 0. If I run it, I'll get true. Type 1, I'll get false because 0 is not greater than 1. We can also do comparison. So, for example, 1 equals 1. Now, before I run it, you can see Python will tell you that you cannot use this single equals to sign because that's what we use to assign variables. In order to do comparison, we need to use double equal sign. If I do this by typing another equal sign and try to run it, I'll get true. You can also evaluate if a value has content. For example, print bool for boolean, and I'll type XYZ. Then run F9, I'll get true. I'm going to copy this and paste it here, and this time I'll leave it as an empty string. If I run it, I'll get a false statement because there's nothing to evaluate in here. If you were to type anything such as 0 in there, it will give you false. Well, in this case, it gave you a true value because it's looking at 0 as a string. Now, if I were to type 0 as an integer, I'll get false. If I were to have empty square brackets, I'll also get false. We can also do comparison in other ways. For example, y equals fish. I'll type x equals bird. What I'll do is I'll use the len statement to calculate the number of characters in fish and birds. So len is a function that will count the number of characters. For example, fish has 4 characters in the word, birds has 5 characters in the word. So if len of x is greater than len of y, and print x has 4 characters, then y. If I try to run it, oops, I have to run the old program. Birds has more characters than y. Now, if I were to remove this and run it again, I'll get no response. So in this case, what I can do is type an else statement, which will print what words that equal number of characters, and I can type len x. Now going back to the statement of credit card application, what if you wanted to know if a person qualifies for a credit card with $50,000 income? So we'll need to declare income as a variable. Income equals to 50,000, and let's assume the salary required for the credit card would be 6,000. If income is greater than salary required, then I can print congratulations, you were approved, you have been approved for the credit card. If the income is less than salary required, then it will print sorry, you do not meet the minimum income required. If I were to run this little program here, I'll guess sorry, you do not meet the minimum income required. This is because the income is less than salary required. Now, what if we were to switch the numbers? So this will be 60,000 and this will be 50,000. And if I run the same process again, congratulations, you have been approved for the credit card. To close this session, we can also use the inbuilt Python function to check if an object is string or not. For example, x equals 5, and if I were to type print its instance, which is a function of Python, x string, and if I run it, I want you to ask if what the response will be. So if I run it, it's false because Python will store the number 5 as an integer by default. If I were to cast it as a string and then run it again, then I get true because x then is a string type. Thank you for watching this lecture. I'll see you in the next one. Hi everyone. In this section, we'll be exploring conditions in Python. In every programming language, there's a concept of if and else. That is, try to perform a task, and if that fails, then perform a different task. Let's explore this concept with some examples. We'll start it by declaring x equals to 100 and y equals to 50. Now we want to find if x is greater than y, so we would type if x is greater than y, print x is greater than y. Now if I were to run this program by clicking this button or the F5 key on your keyboard, it will print x is greater than 5. Now what if I changed the operator to the opposite direction and try to run it? It would not print anything. In that case, I'll need an else statement, which is print y is greater than x. If I run it, it will print y is greater than x. We can also have additional statements in there. For example, using the elif statement. If you were to change x equals 50, y equals 50, and then type elif x equals y, then print x equals y. If I write to this program, it will print x equals y. The if statements also cannot be empty. So if you were to type something like if x is greater than y, and then you do not put anything here, and were to say, for example, print hello, the program will simply fail. So you need to put a pause statement here, in which case your program will run to the end. The indentation is also important. So if you're running this in Spyder, when you press enter key after y with the colon, it will auto indent for you. But if you were to type something here, pause, this would not work. It will tell you that you need to have an indented block after an if statement. You can also have nested if statements. And we'll make a little program here. For example, we want to find out if an applicant applies for a loan and if it qualifies based on the credit score and the income he has. So we'll declare a variables called credit score equals 600, income equals 50,000, and then we'll write credit score required equals 500 and income required equals 40,000. So we'll type if credit score is greater than credit score required, and this and has to be lowercase. If you were to type in caps, it would not work. So you type and income is greater than income required, then print congratulations, your application was approved. I'll just comment out this part. If I were to run the program, and I'll clean this here as well, and the console, if I were to run this program, it will print you, congratulations, your application was improved. What if you were to have a credit score required of 800? It will not print anything. So we'll need to put some statement here. Else print, sorry, your application was denied. In this case, your application was rejected. You can also have or statement. So we'll check for both things. If you have a lower credit score but a higher income, if you meet that threshold, then you will qualify. Because the bank will look at different things. Sometimes you might have a lower credit score but a higher income, and they might give you that loan. So this is how you can use and an or statement. You can also have nested if statements, and I'll comment this part out. You can type if credit score is greater than credit score required. And after it has validated that, then you can do another if statement if income is greater than income required. And then I can print. Let's copy that here. Else, it will print, sorry, your application was rejected. And also we can do an else statement here. So if I were to run this program now, sorry, your application was rejected. Now if I were to reduce this to 500 and run it, congratulations, your application is approved. You can also have if statement in a single line of code. It's called shorthand, and it's only applicable if you have one statement to execute. So you can type, for example, x equals 50, y equals 100. And then you print x is greater than y if x is greater than y. Else print y is greater than x. Okay, I need to run this entire line, and you can see you can also use just a single line. But it's always neat to use this this format. It just makes it easy for you to read and also for someone else. And if you like to save on the line of code, like the scrolls you have to go through, then you can use this option. Thank you for watching this section. I'll see you in the next. Hi everyone, welcome to this session. This is going to be an exciting one because you'll be building your very first program. I know I'm excited. For this session, we'll revisit the bank example from an earlier module where a borrower goes to a bank to ask for a business loan. We'll keep this example very simple, not including interest rate or many other metrics a bank will look into. Rather, we'll just focus on the amount of loan asked and the expected monthly payment to calculate the number of years and months it will take to pay off the loan. To start with, we'll declare a variable called loan amount, and we will use the input function, which will capture the data that a user enters. So in this case, we'll ask a question, how much of the loan do you require? If I run this by pressing the F9 key or this little icon here, I'll get this question. And if I enter 10,000, this is stored as a variable. Now notice that this has a string type instead of integer type. So what we'll need to do is cast it as an integer when we enter the amount. And if you run it again and enter 10,000, now it's stored as an integer. Now what if someone was to enter a comma? So for example, 10 comma and zeros, you'll get this error. In this case, we can use the Python method called replace, which will replace the comma with empty space. So we'll type replace. And notice how Spyder helps you with some of the documentation on what you need to enter. So in this case, the old string would be comma, and then I'm going to replace it with just an empty space. If I run it now, 10,000, and it is stored as 10,000. The next thing we'll do is to print the response that has been entered. So for example, you have put a loan amount of loan amount, and I want you to question if there's an error you can see here. So if I try to run it, it will throw an error. And if I do that now, you can see it's you cannot concatenate string with integers. To fix this, what we need to do is cast the loan amount as integer. And if I run it now, I can see the print statement. Next thing I need to do is calculate the payment plan. So I'll declare another variable called payment plan equals integer input is the expected monthly payments. And this will also tell you that if you make a typo error, Spyder will guide you that hey, there's an undefined input. Well, this is not because there was an extra U in there. That's why the Python didn't know what this is. Now, if I remove it, I can see the color changes to orange. So I can use this input method. And if I run this now, I can get 200, and this will be stored as payment plan. Now I need to do another print statement, which will say you promise to pay string payment and plus it's every month. Notice how it says payment plan. If you want to change it to payment amount, you can just replace this variable. And as you do that, you will see this little circle with an X. It means undefined name because you have to declare the variable to start with. So if I try to run it, it will throw an error. So what I need to do is replace this with payment amount. Now if I run it, 100. And notice how this threw an error because I had not run the payment amount variable. So I need to run it in order to declare the variable before I can go to the next step. So I still have the payment plan here. And if I need to delete that, I can simply type del payment plan. If I hit enter, this will delete the variable from here. So this is one way you can keep your variable explorer screen clean. And it's also, as you build larger programs, the less variables you have, the quicker the program will run. And so if I run this, you promise to pay 200 every month. Now I need to calculate the payment, how many years and months it will take to pay off the entire loan. To do that, it will type time to pay off equals loan amount divided by payment amount. If I run that, that's 50 months. And if I want to store that as an integer rather than a float value, I just need to cast the value as a float. And now it's cost the value as integer, and now it's 50 months without the decimal point. Now what I need to do is calculate the years and months it will take to pay off. So if I were to type years equals time to pay off divided by 12, this will give me the number of years it will take, and months will be time to pay off, and we're here using the modulo method. And if I type 12, this will give me, it will take 2 months to 4 years and 2 months. So if I were to type that as a statement, I'll type print based on the provided info. I'll type another, I'm going to exit out of this program. And I'll type print it will take you plus time to pay off plus months to pay off the loan. So on this, it will tell you that it will take you 50 months to pay off the loan. Now, if I want to know the number of years and months it will take, what I need to do is use another print statement. In other words, string, and I don't need to call integer because it's already stored as an integer. So what I just need to do is type years and then plus years plus tab and here months to pay off the loan. So if I try to run this now, I get the error that I cannot concat. I need to cast it as a string, so that's an error. And if I try to run it now, otherwise it will take 4 years and 2 months to pay off the loan. So I need to add that here. So if I run the whole program now by pressing the F5 key, it will ask you how much of a loan do you require? 10,000. You have requested a loan amount of 10,000. What is your monthly payment plan? I can type 200. You promise to pay 200 every month. Based on this info, it will take you 50 months to pay off the loan. In other words, it will take you 4 years and 2 months to pay off the loan. Congratulations, you have built your very first program, and I hope you can take this knowledge and apply it in some other fields or some other calculations. I'll look forward to the next session with you.